Chevron is a proud sponsor of the Jason Project in association with the Harris County Department of Education, HCDE.
Okay, so the lab this week is going to be over the moving surface from the Jason Project. So everyone has their lab sheets, correct? And their data sheet, correct? And this week we're going to be working with some hot oil and a flame. So we're going to have to wear our safety goggles this week. So everybody go ahead and put on their safety goggles. All right, now that everyone has their goggles on, you getting it there?
Yes.
All right, very good. Now today, students, what I did is I went ahead and pre-prepped the lab for us. On any other day we would have done it, but we're working with a lot of oil. So what I've done is I've taken the pie dish, I've filled it halfway with the cooking oil, and I have put some spice inside and I've stirred it up for you. We have a heat source, which is going to be the little tea light candle, which I will light for you and place underneath in the center of your pie pan, and that'll be the prep for the lab. I'm going to come around, I'm going to light the candle and place it under your pan. While I'm doing that, you need to read through the instructions on your lab sheet. Is everyone good? So, step one today is we're going to describe the effect of the heat source on the oil and the spice. You are, on your sheet right here, you are to draw it and label everything that you're seeing going on in your pan. Now step two today is you're going to take 2 pieces of the polystyrene, okay? And you're going to predict what happens when you place them in the center of the pie pan. So on step 3, what we're going to do is that we're going to draw out on our diagram what we think our pieces of styrene are going to do on our heat source. All right, so go ahead and draw out what you predict our pieces are going to do. All right, so now you're ready. You got all the instructions on what to do. What you're going to do is that you and your lab partner are going to take the styrenes. Okay, not yet, just wait. And you're going to place them in quadrants A, B, C, and D that I've marked on the pan for you. You're going to take them towards the center and set them. Now, you have to be careful. You can't set them really close together because what they'll do is they'll attach. They'll become one big piece. So make sure you have a little bit of room in between when you place them in the oil. You bring it over to your area towards the center. And on 3, bring yours a little bit more over towards the center. And on 3, we're going to drop them. Make sure they land flat. 3, 2, 1, drop. Now this time for your prediction, and we only have 4 pieces left, so we can't all put it in there this time. You need to take 2 pieces, and you're going to predict how you can place it onto our heat source area and make the 2 pieces separate from each other. That's the first prediction. The second prediction with the styrofoam or styrene is that you have to predict how we can have these 2 put on there to where they will crash into each other. Okay? Remember that? What type of tectonic plate movement is that when they come and hit each other? Convergent. Very good. So go ahead and make your predictions of how you think you can do that. Talk amongst yourselves, figure out a way, and then we'll do the experiment in just a moment. And as we watch them, what are they doing?
They're diverging.
They're diverging. They're moving apart from each other. And what kind of tectonic activity is that?
Diverging.
Divergent. What do we get with a divergent boundary? Mid-ocean.
Ridge.
Not a trench. Remember trench? There's going to be this over here, right? Yeah, it's ridge, mid-ocean ridge. Very good, very good. So go ahead and write down your observations. Okay, for our second prediction, you guys say you're going to have them crash together, okay? So which quadrant are you going to put them in? So let's go ahead and get them up there. And on 3, we're going to drop them in there. 3, 2, 1, go. And what happened? And what type of tectonic activity is that?
Convergent.
Convergent. What type of landform do we get with a convergent?
Folded mountains.
Folded mountains? And what's the most famous folded mountain range?
Himalayas.
The Himalayas. Very good. Very good. Go ahead and write down your observations. Now for some questions. What part of the Earth does the spice layer on top represent?
The spice represents a lithosphere.
What part of the Earth does the oil represent?
The oil represents the mantle.
Okay, third question. What does the heat source represent? What part of the Earth does the heat source represent?
The heat source represents the inner core.
So to wrap up our lesson today, we have talked about this type of activity. What is this called? Divergent boundary activity. And this type of convergent boundary. What type of ground formation do we find at this? At this. Folded mountains true and mid-ocean ridge. What do we find at this zone? Folded mountain. What is this zone called? Convergent zone. Very good. Very, very good. Who wants to blow the candle out? Blow the candle out. Blow the candle out. There we go. Very good. Very good.